So there's some properties that come with the summation notation. I don't know that you're going to see a lot of these use for it, but it makes sense and it gives you some practice with the notation. So if you have the sum, and I is going from 1 to n, and it's C times A sub I, and C is a real number. Okay, then that equals, I'll have to write it over here. You could factor out the C for all of them, and it'd be C times the summation of I equals 1 to n, A sub I. Now, A sub I just is representing the term in the sequence. So think about it, if you were going to multiply each term by C, you could factor out the C, add up all those terms, and then multiply it by C. So it's like the distributive property, right? Or the factoring property, you're factoring it out. So those are equivalent. Now, if you have the summation, I going from 1 to n, and you have A sub I, so a sequence with a term plus another generator, well, you could split those up. You could say it's the summation I equals 1 to n of A sub I plus the summation of I equals 1 to n B sub I. So it doesn't matter. You could add up all the A terms and then add up all the B terms and add them together. Or you could add each A and B together and then add those all up. So it'd be the same thing. And then finally we have one similar to the addition one. If you have the summation, I equals 1 to n, and you have A sub I minus B sub I, you could take each A term and subtract the corresponding B term, or you could split it up, add up all the A terms, and then add up all the B terms, and then subtract whatever you get from the first addition minus whatever you get from the second one. Now those squiggly lines aren't part of it, but there you go. All right, so those are the properties that we have for summation notation. There's examples in the book if you want to see.